Finding inverse relations using algebra is trivial. Simply swap x for y and y for x and the job is done. Example A. Find the inverse relation. The inverse of 2x plus 5y equals 10 is 2y plus 5x equals 10. The inverse of 5x squared plus 45y squared equals 45 is 5y squared plus 45x squared equals 45. The inverse of 20xy plus 5y cubed equals 40 is 20xy, or yx, plus 5x cubed equals 40. All right, and there we go. Note, the inverse of 2x plus 5y equals 10 is 2y plus 5x equals 10, which means the inverse of 2y plus 5x equals 10 is 2x plus 5y equals 10. So the inverse of this is that, and the inverse of this is that. If a function is one-to-one, its inverse is a function. It is standard to write functions in function form, which requires that we write y as a function of x. Example B, find the inverse function of f of x equals 2x plus 5. Here's the process. Step 1, replace f of x with y. Then swap x for y and y for x. We'll continue this on the next slide. Alright, so above this dashed line is still the original function. Below the dashed line is now the inverse. So now, once we swap the x and y's, then we solve for y in terms of x. So we solve this equation here for y, and then you replace y with f to the negative 1 power of x. That is the inverse in function form. Note, f to the negative 1x is the notation used for an inverse function. Example C. Find the inverse function of g of x equals 1/4 x minus 3. Alright, so we write the function here, then we replace g of x with y. We'll continue this on the next slide. Then we swap our x's and y's, and now we have the inverse. But to get it into function form, we'll now solve this equation for y, and that gives us y equals 4x plus 12. Then we'll replace y with g to the negative 1 power of x. This is the inverse in function form. Example D. Find the inverse function of h of x equals 1/3 x plus 4. Here's the process. Step 1. Replace h of x with y. Then we'll continue this on the next slide. So now we're going to switch the x and y's. Once we swap those out, we solve for y. Then we replace y with h to the negative 1 power of x, which is the inverse in function form. Summary. F to the negative 1 of x is the notation for the inverse of f of x. G to the negative 1 of x is the notation for the inverse of g of x. H to the negative 1 of x is the notation for the inverse of h of x. This is unfortunate because writing negative 1 in the exponent position suddenly has two very different meanings. In algebra, a negative exponent has a special meaning. X to the negative 1 equals 1 over x. So 2 to the negative 1 equals 1 over 2, etc. Be careful. With functions, this notation means inverse function. F to the negative 1 of x does not equal 1 over the f of x. F of x to the negative 1 power written like this does equal 1 over f of x.